engineer today. I'm sorry.
Engineers too lazy to learn how to code.
Yeah, I don't want to code. Yeah, this is my 3D model. I saw on 11.5 that we're in a fourth 3D modeling software.
Okay. Now we actually get to do integrals over a region instead of just iterated integrals.
Good. One whole oxygen in the subject matter and mine also has not on the subject. We have about like a month left, right? Give or take us less.
August 18th is our last day here. August 14th will be.
Yeah, less. Oh my goodness.
Like 2 weeks, 2 or 3 weeks.
This summer has like 85 years.
I always use contour plot 3D. Because there are just issues when you use plot 3D. So we have several surfaces, y equals 0, z equals 0, x plus y equals 2, 2y plus x equals 6, and finally y squared plus z squared is equal to 4. Now let's see. Total's in the first octant, so we're just going to go all x, y, and z non-negative. What do I go up to? 5 all the way around. And this is all you need. But we're going to look at how hideous it is. That's just terrible. And of course you can zoom, move it around. Oh, that's nice. I wonder if that's new, because I didn't used to do that. It used to like remove the image when you started to rotate.
So is this for finding the like boundary?
Mm-hmm. This is for finding the solid. Okay. I don't like the box. I don't like that mesh. Okay. So we're gonna turn that off. Axis is already on, but we have to set the origin to be 0, 0, 0. It's mesh. Turn off the mesh. But of course there's problems. What axis is what? We don't know. And sometimes the axis is kind of hard to see. So we can do is we can go first axis the label. X, Y, Z. Label style. Let's make it.
How do you use axes true?
That's for just 2D. 3D axis are already turned on, it's just the origin isn't. The origin. That's better. Right, so there's our X, there's our Y, there's our Z. And typically what I'll do is, obviously legends, and also set plot style, it's style. Set the opacity to 0.5. So you can kind of see through. And now the idea is we want to try and get a good view so we can see the solid in question.
Is there not a way to just shoot the boundary?
You can probably do a region plot 3D, but you still need to know how to set the bounds. So this is just the best option. That kind of looks good, actually. Maybe a little bit more.
So this isn't that, like,
This is our solid. Green to the red planes. This plane here to the cylinder, and then this plane here up to the cylinder. We have to use this so we can describe the solid W. So that's.
I guess if you're, because this is just set G, set of region.
Well, the region. Define the region so we can set up the integral.
Okay. Could you not, isn't the region defined by telling me how it's down?
Well, it is, but that's not a good enough description for us.
Well, I guess why would
What are the bounds for X? What are the bounds for Y? What are the bounds for Z? Based on what they just told me.
wouldn't be 0 to y
For what?
z? It's 0 to
Of course, they don't
cos
copy the
squared
integral.
plus c squared, and then for y, it's 0 to the same. And then x would be
Damn it.
x plus 5, and then 2y
Oh, crap, I'm not gonna.
plus. Could you use the spherical?
I'm gonna have to. Yeah, just that. Z goes from 0 up to the cylinder, right?
We can't see that.
Now we have to choose, do we want X next or Y next?
For the integral?
What's our middle component going to be? It's our inner with Z, right? So you want to do dz dx dy or dz dy dx?
Probably zy.
You could, but it's a bit more hideous.
What was that?
Because if you do y next, we're going up this way, right? This is the x-axis. Y goes from 0 to the red plane until we hit a certain point, 2. then it goes from the green to the red.
Oh,
That require two regions, two solids.
gotcha.
Versus if we just do X, this is Y. This is the Y axis back here.
Right.
As we slide over that, X would always just go from green to red. Which means we should probably do dx dy.
Gotcha.
So it's going to start green, end at the red. That's what? 3 minus x over 2? No. 6 minus 2, actually. I'm doing it in terms of. And then what is y going from? Y would go 0 to where the green intersects the cylinder, which is 2. 0. There's the solid. Fubini's theorem gives us this. Where D is the projection of the solid onto the xy plane. But we already described that. That whole thing is D. So I won't be doing that again, but that's what Fubini's theorem says. And then you use Fubini's theorem again on the double interval of the domain, which allows us to write this.
It's 2 minus y, correct? You know the lower bound?
2 minus y, yes. Now you just evaluate. I'm debating whether I want to use a CAS or do it by hand. Probably for the sake of how much you just use a CAS. Because then you have no problem evaluating that. And so when doing a triple integral, you can again do the nested, like we did for the double, or just set it up the same way. Right? What are we integrating? Z, and then you want to do outer limits, middle limits, inner limits. And we get 26 over 3.
So, when you're evaluating, because you're doing easy and dx, and when you get dx, you don't have as everything constant.
No, because the integrand would have no x in it at that point, right?
Yeah.
So just be whatever the integrand is, times upper limit minus lower limit. And there's that. Find volume of the paraboloid, z equals 2x squared plus y squared, or volume of the solid bounded by the paraboloid, z equals 2x squared plus y squared, and the cylinder z equals 4 minus y squared. So, first thing to recall, volume as a triple integral. Just the integral of the volume differential, right, over the solid. So obviously our goal then is to describe W. Two things we have to plot, right? Z equals 2x squared plus y squared, and z equals 4 minus y squared. Let's go minus 5, all the way around. Just to start, well, maybe there's one there we need to. Mesh, box, set, origin to origin. Axes. Legends. Style. And instead of rotating it, I can also do this. Pick a point to view it from. So Mathematica is weird. should be from the front, right? They'll be looking down from the x-axis. Except, look how it does it. It does it along the y-axis. It treats y as depth and not x. So viewpoint right would be looking straight down the x-axis. And then it's from here I can just rotate it as needed. And that's typically what I do. I choose my viewpoint to be the right and just kind of rotate it as needed. We can try to reduce the viewing window, and I think I'm going to. Z is obviously positive. Let's go change that. And I don't know, maybe do x and y -3 to 3 instead. Actually, I think I can use it even further than that, but I could go actually -2 to 2, right? But that should be good enough. This should get us what we want. Z. We go from the orange up to the blue, right? X and Y. So I think what I'm going to do is, before I mess with this any further, that kind of looks good. Just take a snapshot of this and get it onto the slides. We now need to define our domain, or the region on the xy plane. Essentially, then what we're going to be doing is doing this. We're going to view it straight down. Your region is that the boundary of the region is the intersection of the two surfaces. What is that? That's a circle, isn't it? Here's how I'm going to write it down. Start with Z, we said it's going to go from the orange to the blue. Again, now if we're looking straight down, that curve of intersection is a circle of radius 2, isn't it? We want the entire thing. So you can choose dx dy or dy dx. It actually does not matter in this case. I'm going to go with dy dx. That is the total description of W. I am actually going to write it this way this time. And there's going to be 4 minus y squared minus the 2x squared plus y squared, right? That's what we have. And the advantage of writing it this way as we've already seen, isn't that region circular? Isn't it a polar region? Can't write it that way. Right. Write the integrand in polar. What is it? Yeah, I want the integrand in terms of polar.
E or cosine theta squared plus r sine theta squared.
What's the integrand, first of all? Without comparing to polars, what is our integrand?
R integrand is 4 minus 2x squared minus 2y squared. Okay.
Now write that
Okay. So
in polar.
4 minus 2r cosine to our sine.
You're doing too much. What's x squared plus y squared?
Oh, shoot.
Just factor out the negative 2.
Okay.
You're not wrong if you do what you're doing,
Yeah, because
but that still simplifies.
x equals r cosine.
That would simplify. What is the area differential in polar?
dr. Or d theta here. That's the- Well,
You just made the most common mistake.
isn't 0 to 2 is the radius, and then 0 to 5 is theta? Oh, it's r d theta. So you have to account for the.
The derivation for that is in the slot, is in the video for polar. And it shows where that extra r comes from. But it is r d theta. Oh look, there's no theta anywhere. So we can integrate with respect to theta first, and that gives us 2 pi. Factor out 2 as well. That is what they're going to be left with. Not 2, sorry. Root 2. The radius is root 2, not 2. That is going to give us just 4 pi. Right, you get r squared from 0 to root 2 is just 2, right? Then you get r to the 4th over 4. Well, 2 to the 4th is 4. That becomes 2 minus 1, which is just 1. So you left with 4 pi. There's our line. And for average value, we're going to look at a simple solid. We want the average value of y e to the negative xy over the rectangular prism 0, 2 cross 0, 3 cross 0, 2. And we don't need to plot this solid because it's a box. Or not a box, it's a prism. Box is square. Average value. This way. Average value of a function over a solid is 1 over the volume of the solid times the integral over the solid of the function. What's the volume of our box? Yeah, I'm calling it a box. It's not really this prism. What's the volume of our prism? A cube? No, this is a box. Box can be rectangular. I mean, you can do an integral. Think back to geometry. They're given a box. What's volume? Length times height times depth.
Is that not the same thing as length by width?
I didn't hear that. I just heard length by width.
Oh.
So if you said by height,
I
then
did,
that's right.
I did say it.
That's right.
That's why I was so confused.
Length, height, it's length times height times depth, which is just 12.
That makes, I was worried for a second.
Yeah, I didn't hear you say height. I just heard length by
I
width.
was thinking, why is that wrong?
Because I said it is. Average value then, 1/12 times the integral over the box. Well, because this is a box, setting it up is easy. I'm going to go, what order did I use? I'm going to do z first, and then xy. Z is the obvious choice to go first because there's no Z anywhere. No, I did that wrong.
Okay.
Y is on the outside, so that's 0 to 3, and then it's 0 to 2. Right, and again, you could just plug this into a calculator. So I use 1/6 on the outside, I've got the 1/12. I always do that, I drop that 1/12.
Is it any reason to do dz dx to one instead of another orientation?
Well, Z, because there's no Z, so do that first. The integrand doesn't have Z in it at all, so let's just get that out of the way first. And dx dy has to be dx dy.
What's that?
No, I don't. I guess it doesn't have to be. You could do dy dx, but if you do dy dx, you have integration by parts.
Which is kind
And if you set your dv to be e to the negative xy, yeah, if you set your dv to be e to the negative xy, that doesn't have an antiderivative, which means integration by parts fails. So yeah, it has to be dx dy.
interesting. Okay.
Because now you can just do u sub. Partial of negative xy with respect to x is just negative y. We have the y. Then it's e to the negative xy evaluated, not y, x from 0 to 2. We're going to switch the order so I can get rid of that negative out in front. E to the 0 is 1.
What happens if we
I switched the order so I could pull out the negative, so I could pull in the negative.
Oh,
I did not, I did bottom minus top. So I just flipped the order so I could get rid of that negative. If we evaluate this, 1/6, and I'm going to erase that because I'm going to fully simplify it without going through the slide. Okay, we're going to have 1/6. No, that one's easy, right? That's just 3. Plus, because you have to be multiplied by a negative because it's even the negative 2y. We're going to multiply by a negative 1/2, so that becomes minus negative 1/2, which is plus 1/2. E to the negative 2y evaluated from what, 0 to 3? Oh, 0 to 1. And at 3, it's negative 6. Even negative 6. And then I'm going to simplify that whole thing. When you simplify that, why did my eraser stop working? There we go. You got 1 plus 5 e to the 6 all over 12 e to the 6. Okay, good. As far as hardest part is setting it up.
I guess that's like the majority of these.
Now here's the fun part. On a quiz, you have access to Wolfram, right? What about the exam? You do not. And your calculator cannot do three-dimensional plots.
Could you not just? Oh, no, no.
The TI Inspire cannot do a three-dimensional plot. That sucks. You better be good at visualizing it. Chances are it's a really complicated solve. I'll just give you the plot on the exam. Which means if I don't give you a plot, you don't need one to visualize it. It should be pretty straightforward, pretty obvious what the ends are.
I was going to say, I thought you were about to say you couldn't take a trip in the obviously. No, on the calculator, I guess you would have each integral.
You have to do the nested. You have to do the nested integral. Yeah, integral of integral of integral.
Oh, okay. And then I guess you would define each one.
We'll write it down here. I don't know if that's good.
Looks good.
Cylindrical and spherical coordinates. Here's Fubini's theorem in cylindrical. Again, notice. Pen would work, that would be nice. Pen would work, that would be nice. Go. Okay, so notice in cylindrical you get an extra r. Right, so dv becomes r, dr theta dz. And Fubini's theorem for spherical. Notice what dv becomes. Rho squared sine phi d rho d phi theta. Alright, so let's evaluate this.
Oh, Jesus.
But you should notice that cannot be done in Cartesian. So now the question is, do we want to switch to spherical or cylindrical? Spherical. If you look at the region, that is part of a sphere. Right? So the question is, what part of the sphere is it? Y is non-negative. And then both Z and X, everything. Well, if Y is non-negative, that would be what, the right hemisphere?
Why is the water so non-negative?
Or something. Mixing up the arm. The front hemisphere. Theta would go minus pi over 2 to pi over 2 then. It's quadrants 1 and 4.
Yeah.
Since Z is both positive and negative, there's no restriction on fate. And what is the radius of the sphere?
So,
There's your description. So converting this into spherical, identify the integrand. What's the integrand?
the integrand is 1 over x squared plus y squared plus z squared all the way through.
So what is that in spherical?
That is r squared plus.
There's no R in spherical.
Oh, there is no r squared.
Sphericals rotate the thing.
Sine cosine rho squared sine
Just one over rho.
just 1 over rho.
X squared plus y squared plus z squared is rho squared.
Okay.
Right.
X though would be x by itself though would be cosine.
Rho cosine theta sine theta.
Oh, so this uses
It's the spherical coordinates.
each of them use all three.
No, z is just rho cosine theta. Now the volume differential. Rho squared sine phi d rho d phi d theta. Oh. There's no theta anywhere. Length minus pi over 2 to pi over 2 is just pi, isn't it? And if you look at that integrand, isn't that a product of a function of rho and a function of t? So we can just do this. Which makes this really nice. Rho squared over 2 from 0 to 7, 49 halves, times that pi. Now integral 0 pi sine of phi. Negative cosine of phi from 0 to pi, right? What's cosine of pi?
Cosine plus
What's cosine of pi?
Cosine of pi is -1.
Negative 1. Cosine of 0 is 1,
yeah.
which means that integral's 2. There you go, 49 pi. And that is something that you may want to write down on your sheet. So you don't have to waste time always doing it. Because that may turn up a lot.
That, you know,
So we'll just use that in the background. You evaluate the square root of x squared plus y squared over the solid bounded by the circular paraboloid 1 minus x squared minus y squared and the xy plane. Circular paraboloid e 1 minus x squared minus y squared. What's the xy plane? What's the equation? Or the relations matter. Start this way. Oh, we're clearly gonna switch z 0 to something, right? Let's go 0 to 2. And what about x and y? Let's maybe look at minus 2 to 2. See how that works out. That worked out pretty nicely, didn't it? Solid is this solid here. Just orange. So we can shrink this down even further if we really wanted to. Everything's going to be minus 1 to 1. Except for z 0, there's b 0 to 1. And why not? That looks good. What coordinate system do you want to use? Can't use polar. Polar's two-dimensional. This is three.
Sphere.
Spherical?
Yeah,
So what would your row be?
yeah, because this is issue.
Cylindrical would be your best bet. You could use spherical, but it's going to be really ugly. Because your rho is going to be a function of phi.
Yeah.
Theta is going to go 0 to 2 pi, right? It's the entire circle. R is going to go what? 0 to 1. And then Z will go 0 to 1 minus R squared. What is the integrand? So in other words, what is the function that we're integrating?
X squared, y squared, y squared.
Write that in cylindrical coordinates.
It's R squared, y squared.
Which is just what? What does the volume differential become?
R, dr, together.
Volume requires 3.
Yeah, I'm trying to remember the twice ones. RGZ.
Maximum coordinates are theta z. So your differential is dz dr to theta. Oh, that's nice. There's no z and there's no theta. So we kill two birds with one stone. Integrating with respect to theta is just going to give us 2 pi. Integrating with respect to z, just give us 1 minus r squared. Z goes from 0 to 1 minus r squared.
Oh, no.
That's the integral you're left with, right? R cubed over 3, r to the 4th over 4, it's 2 pi times the third minus a quarter. What's the third minus a quarter? I'm sorry, it should be minus the fifth, right? What's the third minus the fifth?
Over wait, oops. 2
Let's do 15s. 4 pi over 15. This shouldn't require a plot. We're integrating over a ball of radius 2, which is just a sphere of radius 2. What's the integrand?
Does he have to be greater than 5? Or less than 5?
Number phi is the angle of declination. The angle measured with respect to the positive z-axis. So it's 0 pi. What is our integrand?
Squared plus less is equal.
Write that in spherical.
Just phi squared or 1 over phi.
Not phi squared.
It's just doesn't wait. That doesn't phi squared.
That's phi squared.
Oh, rho squared.
Rho squared.
Sorry, rho squared. So,
And what does the differential become?
Rho d rho d
What are you missing?
rho no rho something times oh sine.
Oh, there's no theta, right? That's 2 pi. But then you have the integral sine phi d phi from 0 to pi. What did we just say that was?
Oh, never mind. Repeat the question.
What's the integral from 0 to pi of sine phi d phi?
You said that was 2.
Becomes just 4 pi, the integral 0 to 2 of rho to the 4th d rho. What's 2 to the 5th? Let's actually just leave this 2 to the 5th for right now. Because 4 is 2 squared, right? So 2 squared times 2 to the 5th is 2 to the 7th. What's 2 to the 7th? Be all over 5. What's 2 to the 7th power? Told you.
Oh, no, that's.
It's 128. There's the integral.
Yeah, I don't know if that was that. Hold on. It's because you're in that position.
Just like a binary.
Because you're in that position.
There's nothing to do with that. It's an application of math. Volume of the solid. Again, remember volume is just the integral over the solid of the volume differential, right? So let's take a look at this solid. Oops, that's not working. So we're going to go up a little bit higher on Z. But I can also change it to 0, right? Double it. And that was 2, right? Oh, now what does that look like? 8? For Z? And what about X and Y? I don't know, 3. Let's just look at 3. That's good enough. The cell that we're trying to find the volume of is that pill shape. Right? It's that. What coordinate system? Cylindrical will probably be the best here, yes. Theta, 0 to 2 pi, do you see that? What about R? So R, we're going to look straight down.
I was just it's square root -2.
It's just 2. 2.
Oh, okay.
Two ways you can look at it. First, you want to look at the curve of intersection, which is that inner circle that has radius 2, or just set the two relations equal to each other. You'll get 2x squared plus 2y squared equals 8. X squared plus y squared is 4. That is the circle of radius 2. And now what about z?
It's R2. R to -1, and then R squared to 8.
There is your region. So the integrand is just 1, so that's easy. What is the volume differential in cylindrical?
So that's
So what is dV in cylindrical? The volume differential.
oh, that would be
Did
oh, sun. Power.
R dz dr d theta. No theta anywhere, right? So integrate with respect to theta gives you 2 pi. There's also no z, so go ahead and integrate with respect to z. It'll be 8 minus r squared minus r squared. which does have a 2 common, so let's factor that out. You're left with 4r minus r cubed, right? dr. Two r squared. 2 times 4 is 8. Then it's going to be r to the 4th over 4. 2 to the 4th over 2 squared is just 2 squared, right? 8 minus 4 is 4. Get a volume of 16 pi. So at this point, I have 2 options. I think this one I'm going to do. So we want to find the volume of this ellipsoid. So let's do this. There's the ellipsoid. So here's what I want you to do. As a group. Why don't you describe that region? Maybe. Let me make this extra credit. So the remaining 13 minutes, describe that region. If you get it perfectly right, I'll give you +2 points onto the final exam.
For me?
Well, for the group, but I'm sure they'll be back.
Okay. Yeah. If we describe this perfectly, we get 2 extra credit points on the exam. Okay.
And it's a group, so.
If we describe this correctly, we get 2 extra credit points on the exam.
Yeah. Or to describe it as in.
So what we've been doing, so you first have to decide, do you want cylindrical or spherical, and then write it as a set,
Okay.
like we've been doing.
Okay.
And this is group, so you have until 3:15 to do it, which is when class ends. It's just under 12 minutes.
Spherical? Yeah.
So,
I think, yeah, spherical.
I'll also show this. Lunch homework. Is due next Monday. The third group assignment is due next Monday. I'm going to keep that due date, whether I give another group assignment or not. And start thinking about that reference sheet.
So
And I'm obviously not going to help you because it's extra credit.
spherical here.
Yeah, I think spherical might be the best option here, but
Yeah, because